Okay, pre-calc, here is the intro to vectors part 2. Last time we talked about what a vector is and the types of vectors and how to prove that vectors were equivalent. And now we're going to talk about what it means to have a vector in standard position. Okay, standard position is when the initial point of a vector is at the origin. Okay, so last time we talked about the initial point and the terminal point. So now if that initial point is at the origin at 0, 0, then it's considered to be in standard form, in standard position, I'm sorry, standard position. So you have a little picture of this and with a vector drawn. And here's a point right here. And we're going to call this point A, B. And this vector we'll call V, and this angle right here we'll call theta. We knew we couldn't get away from angles. So if a vector is in standard position, this picture of this vector is standard position because its initial point is here at the origin, then, and the terminal point is AB, then the component form of a vector of vector V, this vector V right here, is A, B, like that, with those little pointy parentheses. That is the component form of a vector. Okay, the magnitude, which is how long it is, and the direction angle of theta right there of a vector given in component form can be found using the following. The magnitude, we're just going to find using the distance formula, but now one of our points is 0, 0, so it simplifies just to the square root of a squared plus b squared, and the direction angle, theta, can be found with the formula tangent theta equals b over a. Look at these. These should look very familiar to you because those are the same types of formulas we used last chapter. We always had tangent theta was y over x, and if you look over here, b is y, a is x, and we found different distances and r's and things like that using the square root of a squared plus b squared or x squared plus y squared or whatever. Here we're calling them a and b. So here the component form is AB, and these are the formulas you're going to use to find these. And you're going to use your calculator and the inverse tangent button for most of these to find the theta. We're not going to use the unit circle for this. We're just going to use your calculator and we're going to get degrees. So make sure your calculator's in degrees. So let's look at number 1. Okay, we've got a component form of a vector R of 7, 24, and we're going to find the magnitude and the direction angle for this. So the magnitude is easy. Whoops, it's not V, it's R. And that is going to be the square root of 7 squared plus 24 squared, which equals the square root of 625, which equals 25. So there we have our magnitude, and our angle, we need to make sure we know which quadrant it's in, because remember, your calculator is only, I'm going to make a little unit circle over here. If you put in a positive tangent into your calculator, if you do inverse tangent and a positive, it's going to give you something in the first quadrant, but also the third quadrant gives you positive tangents. So if your angle is in the third quadrant, then you're going to have to do something to that angle. Same thing if you put in a negative tangent, it's going to give you something down here into this fourth quadrant, except it's going to be negative. And so you're going to have to change it depending on which quadrant it's in. So look at this problem right here. 724 is in which quadrant? It's in quadrant 1. So we don't have to worry about it. Our calculator will give us the angle that we need. Tangent theta equals 24 over 7. You're going to put that in your calculator, and you're going to put inverse tangent of 24 divided by 7, and you get 73.74. So theta equals 73.74 degrees. So our direction angle is that, and our magnitude is this. And we have the answer that we need. So let's look at number 2. And remember, you can pause this and try it yourself so that you can see if you can get the right answer. N equals -3, -1. What quadrant is that in? -3, -1, 1, 2, 3. This is in quadrant 3. Okay, so we're going to say, first of all, let's find the magnitude. That's easy. Square root of -3 squared plus -1 squared. But remember that these negatives all turn positive because we're squaring them. And we get 9 plus 1, or the square root of 10. My equal signs don't work. And that equals about 3.16. There's our magnitude. Tangent equals -1 over -3, which is positive 1/3. So you put this in your calculator, and you're going to get inverse tangent of 1 divided by 3. You're going to get 18.43. But is that in quadrant 3? No, that's in quadrant 1. So how can you change something that's an angle right here? How can we change that to an angle down here? We're going to add 180 to it. And we get 198.43 degrees for our theta, and about 3.16 for our magnitude. So if you are in quadrant 3, okay, quadrant 3, you have to add 180 to the answer that your calculator gives. That's how you solve that. Let's look at number 3. V equals 8, -12. What quadrant is that in? 8, -12. That is in quadrant 4. So let's start with magnitude. Square root of 8 squared plus -12 squared. That gives us square root of 208, which is 4 times the square root of 13, which is approximately 14.42. There's our magnitude. Our direction angle is going to be -12 over 8. Tangent equals -12 over 8. So you put that in your calculator. And you get theta equals -56.31. But we don't want a negative angle. We want a positive angle. That's giving us this angle right here, the negative of it. We want this angle. So what are we going to do? We are going to add 360, and we get 303.69 degrees for our theta and 14.42 for our magnitude. So if your angle is in, or your vector is in quadrant 4, you are going to add 360. The first one that we did on the first page, if it's in quadrant 1, you don't have to add or subtract anything. You're all set. Quadrant 3, you add 180. Quadrant 4, you add 360. Let's see what else we're going to do. Number 3, let's look at number 4. Our vector is -11, 6. And what quadrant is that in? -11, 6. That is in quadrant 2, right here. So let's start with the magnitude. Square root of -11 plus 6 squared, those both squared. We get the square root of 137, which is approximately 12.53. There's our magnitude. Those are easy. Now let's do our tangent. Theta equals 6 over -11. You put that in your calculator, and what do you get? 6 divided by -11. You get -28.61. But we don't want a negative. That's giving us this right here. And we in a negative form. And instead, we want this angle over here. So how do we do that? We don't want that angle. We want this angle right here. So we're going to take, we are going to add 180 to that. So our theta is 151.39 degrees. There's our theta. There's our magnitude. Quadrant 2, we add 180. So back over to here, quadrant 3, we add 180. Quadrant 4, we add 360. Quadrant 2, we add 180. Quadrant 1, we just keep it the same. Okay, let's look at number 5. This might be a good time for you to try one by yourself. So you could just pause, try it by yourself, and see if you can get the right answer. -2, -8. What quadrant is that in? -2, -8. That is quadrant 3. Finding the magnitude is the square root of 4 plus 64, which is the square root of 68. Oh, 68, which is 2 times the square root of 17, or 8.25. And our tangent is -8 over -2, which is 4. If you put that in your calculator, you get theta equals 75.96, but that is not in quadrant 3. An angle, 75-degree angle is in quadrant 1, so we have to add 180, and we get 255.96 degrees. And there's our theta. Here is our magnitude. And one more, number 6. We might as well finish this out. A equals 14.5. What quadrant is that in? That's quadrant 1. They're both positive, so this is going to be a quick one. This will be 14 squared plus 5 squared, which is the square root of 221, which is approximately 14.87. For the magnitude, our tangent is going to equal, our tangent theta is going to equal 5 over 14. And if you put that in your calculator, you get theta equals 19.65 degrees. There's your theta, there's your magnitude, and we're done. We don't have to do anything with that theta because it was in quadrant 1. All right, that's how you find magnitude and direction angle if the vector is in standard form, and it's in component form. It means that the initial point is at 0, 0. So let's look at the next page. The next page is we can write any vector that has an initial point that's not 0, 0. But let's say its initial point is x1, y1, and its terminal point is x2, y2. We can write this in component form by this formula: x2 minus x1, y2 minus y1. Now, this is very important. Usually when we use slope formula where we have like a y2 minus y1 or an x2 minus x1 in slope, or in the distance formula, we always say it doesn't matter which point you count as the x1 and which is the x2. It matters here. The terminal point has to go first and the initial point has to go last. We do terminal minus initial, terminal minus initial. It matters. The direction matters. If you do it backwards, then you'll have the wrong sign. You'll have negatives when it should be positives, or positives when it should be negatives. So let's look at number 7. We've got CD. Okay, with C being 3, 5 and D being 6, 3. And we want to put this in component form. So that's going to be 6 minus 3, 3 minus 5, which is 3, negative 2. So let's draw a little graph over here to see exactly what we just did. Okay, actually, okay, so C is 1, 2, 3, 1, 2, 3, 4, 5. So here's C, that's our initial point, and D is 1, 2, 3, 4, 5, 6, 1, 2, 3. Here's D. So here's our vector right here. So what we're doing is we're moving this vector over so that it is has an initial point of 0, 0. So now in component form, it's 1, 2, 3, 1, 2. Okay, there's our new vector. See how we moved this vector right here? And we just moved it right over here so that C was now at 0, 0, and D becomes this point, 3, negative 2. That's what we're doing. We're putting it in component form so that it starts at 0, 0. So let's look at number 8. I won't use yellow. Okay, we've got RS. So we have R and, whoops, S. So to put this in component form, we're going to take negative 2 minus 5 and 1 minus 10, which gives us negative 7, negative 9. So again, let's look at our little, let's see what this looks like. 1, 2, 3, 4, 5, 6. Okay, so R is 1, 2, 3, 4, 5, 10. Here's R. S is -2, 1. So here's our vector. And we changed that into -7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. We changed it into, here it is in component form. We just took this, we moved R down here to 0, 0, and that moves S down here to -7, -9. That's what we're doing with putting it in component form. So let's look at the next ones. It says give the component form, the magnitude, and the direction angle for each vector. So now we're putting everything together, what we did on the front page and what we did here. So let's look at this. Number 9, we've got M is 2, -9, and N is 4, 1. First thing we have to do is put it in component form. Okay, the component form is going to be 4 minus 2, 1 minus -9. Remember, order matters. N is the terminal. We do terminal minus initial. So the component form is 2, 10. There's our component form. Now we can do what we did on the front. We're going to find the magnitude, which is 2 squared plus 10 squared, which is the square root of 104, which is 2 times the square root of 26, or approximately 10.2. There's our magnitude. Our direction angle is tangent theta equals 10/2, which equals 5. What quadrant is this in? Right here. This is in quadrant 1. So we don't have to worry about adding 180 or 360 or anything. We can just put this in our calculator and we're going to get theta is 78.69 degrees. So over there at the side, component form is 210, magnitude is 10.2, and direction angle is 78.69 degrees. All right, let's look at number 10. Number 10, let's put it in component, well, I'll write them down. A is 9, -3. B is -4, -1. Putting it in component form, we're going to have -4 minus 9, -1 minus -3, which equals -13 and 2. Right? There it is in component form. What quadrant is this in? -13, 2. This is in quadrant 2. So we're going to have to add 180 to whatever we get on from our calculator. So let's see, let's start with the magnitude. Equals the square root of -13 squared plus 2 squared, which equals the square root of 173, which is approximately 13.15. Tangent theta equals 2 over -13. So theta equals, I'm going to do it right here, inverse tangent of 2 divided by -13. You get -8.75, and we have to add 180. So theta equals 171.25 degrees. Okay, over here at the side, our component form is -13, 2. Our magnitude is 13.15, and our theta is 171.25 degrees. That's number 10. Let's look at number 11. Number 11, we've got J is 1, 3, K is 7, -4. First, let's do our component form. 7 minus 1 -4 minus 3, which becomes 6, -7. What quadrant is this in? 6, -7, that's quadrant 4. So let's start with our magnitude of JK, which equals 6 squared plus -7 squared, which equals the square root of 85, which is approximately 9.22. Tangent theta equals -7 over 6. So theta equals inverse tangent, -7 divided by 6. You get, and from your calculator, -49.40. Okay, but we don't want a negative, so we're going to add 360, and we get plus 360, 310.60 degrees. So here's the component form, here's the magnitude, here's theta for number 11. And the last one, let's look at this one. Number 12 is a little bit different because we have to find, in 9 through 11, they gave us what the points were. So now they don't tell us what the points are, we have to find them from on there. So the initial point is -1, 4, and the terminal point is 1, 2, 3, 4, 1, 2, 3, 4, 1. And they don't even tell us what they are, they just tell us that the vector's name is C. So to find the component form of that, we take terminal minus initial, which equals 5, -3. And to find the magnitude, we're going to take 5 squared plus -3 squared and get the square root of 34, which is 5.83. And what quadrant? We forgot to do that. What quadrant is 5, -3 in? It's quadrant 4. So tangent theta equals -3 over 5. Theta equals inverse tangent of -3 divided by 5 is -30.96, but we have to add 360 to that since it's in quadrant 4, and we get 329.04 degrees. There's our theta, there's our magnitude, there's our component form for number 12. Okay, so one more thing before we're done with this one. Vectors are equivalent if and only if they have the same component form. So in the last video, we proved that vectors were equivalent by finding that their magnitude was the same and their direction was the same. And we used the distance formula for magnitude and the slope formula for direction. Now all we have to do is put them in component form. If their component forms are the same, then they are equivalent. So we don't have to do all of that. So let's look at number 13. We've got AB, where A is -3, 6, and B is -7, -2. And we have CD, where C is 3, -1, and D is -1, -9. So we're going to put them in component form. AB is terminal minus initial, terminal minus initial, which is -4, -8. Over here for CD, terminal minus initial, terminal minus initial, which is -4, -8. They have the same component form, so that means we can say that AB equals CD. The vectors are the same. Okay, let's try number 14. We got A is -9, -2, and B is 0, -8. And we have C is -5, 2, and D is 4, 8. So let's put them in component form. AB is going to be terminal minus initial, terminal minus initial. So we get 9, -6. And over here, we get terminal minus initial, terminal minus initial, and we get 9, +6. They are not the same. So that means AB does not equal CD. Okay, so that's the end there of the introduction to vectors. So go ahead and work on your homework and see how you do, and let me know, as always, if you have any questions.